Tesla Colt here, and I've got something pretty interesting to show you. I have here clamped in this clamp here one of my Epsom salt crystals right there, as you can see, and that goes to the black lead on the multimeter here, which is set for DC voltage. I'm going to take the positive lead here. I'm going to touch this crystal. Let's see. There we go. A third of a volt directly off the crystal. I touch different points and I get different voltages. There we go. That's pretty interesting because this crystal is totally dry, so there's no chemical reaction going on. This is some type of crystal electric effect going on here. I don't know what to call it, maybe piezoelectric, but I'm not having to really put pressure on the crystal. It's just energy seems to be coming from it. Now I'm going to unhook this lead. Over here I've got, this is Rochelle salts, and let me see if I can set this up so you can see everything. Now I put the ground lead to the pan. It's an aluminum pan. Touch the top of this crystal. Alright, same deal here. I touch different locations and I get different voltages. Let's try this one over here. So there's the voltage coming off of these crystals. I'm sure the current is extremely low, but they are definitely converting power from some sort of source. Anyhow, I just thought that was interesting. Look at that. That is freaking cool.
Okay, here's the lab experiment for the DC circuits part of the class. This is the lemon battery, the lemon cell, the L cell. Got a piece of copper wire from a speaker. Got a galvanized nail. Got a bowl with lemon juice in it to use because I don't have a lemon. And I've got my multimeter here. I've also got some LED lights from a flashlight I took apart, although I don't seem to understand why these lights won't work. It could be the voltage, I suppose, is not quite enough to get them going. But I've tried. But I will do the experiment now. Got the galvanized nail in there. I put the wire in there. And I'm going to check to see if there is... I'll get a little bit better view of the multimeter here. Okay, I'm going to set it for, we'll go with the milliamps, go to 50. Actually, we'll go to 0.5. See if we've got at least 0.5. Got my positive end on the copper wire outside of the dish. negative end to the galvanized nail. And it looks like we're getting a reading of about 3, 2.5, or 3, about 3 milliamps. I believe I'm reading that correctly. Okay, oops. If I go to volts, and go to the 10, try the same thing, positive on the copper wire, negative on the galvanized nail. There is extremely slight movement. So little movement that I can't really get a reading from it. Excuse me. I'm gonna check our ohms while we're at it. See what our resistance is. No resistance. That's moving right through there. No problem. And it shouldn't show anything, but I'll put it on AC. Put it on low, down on 10. It is showing that there's, I don't know if I understand that, 10. And it's showing some AC voltage there. I don't understand that. Anyway, I'll try the light bulb too. Try a different one of these 3. These were all working when I just took the flashlight apart, so put one end here. Put one end of the light bulb on this wire. I will take the other end, put it on a wire here. If I can get it on there. Okay, and now I'm going to touch the nail, see if we get light. Not getting any light coming out of this bulb. But I've tried. And I can see if try this one more time, because part of the wire fell out of the dish. So try that. Try that. And this. Still no. Still no light. Oh, we made an attempt. Okay, so that is my experiment. I hope this is sufficient with a bowl of lemon juice. And the speaker wire uses copper wire. I will try to interpret my results from the multimeter if I can. Thanks.
Recording, okay.
load is taking a little bit there.
Yeah.
Oops. What do you think? This is going on the internet, by the way, this extra footage.
Okay.
So, America, call your president, call your vice president, call your congressman, your representative. Let's put some people back to work, get some clean energy, keep the work in this country. About all I can tell you for now. Just keeping forging ahead and never looking back. America can do it. America has got all the talents right here that we can do anything. We put our minds to it. Cut them off here, or you can cut them off here. Pretty quiet though, you know.
Yeah, it is.
These are where my other two set of magnetic turbines will go. And also here, so this motor will actually adapt to this hole and this hole or hub, and they sit right here, and then another set, and it goes on and on. We don't really know how far because just need to get more research and development in it. That's like any other invention. It's invented in this country or any other country. And I'm going to power it back down now. I'm not sure exactly what that one's hooked to. Huh.
That top inverter, wasn't it? What you flip a switch?
Oh, you think it is?
Yeah, I think that's how you, the top one.
The top one?
I believe so.
Okay. I'll just cut it off there. Then I cut off my inverters. And then I'll power it down. I'm just gonna I can cut it off all at one time.
That's what I was wondering, if you could just shut her down.
Yeah, I can hit the stop button.
It stops fast, huh?
It'll stop it, won't it? Magnetic repulsion, or magnetic retraction, or magnetic attraction, or north against north, south against south, or north and south together. It works all three ways. And that's the take. Thank you, man.